Good morning. Well, it's morning for me at least. It's 5:30. I'm drinking coffee out of my Polar Express mug. Very special. We're going to work on finding slope from a graph today. The answer key to the homework is posted on Google Classroom under yesterday's post. So as we go forward, just keep in mind, no matter what, in order to find slope, you need 2 points. So once you find the 2 points, you can either make a data table and find the slope, may use the slope formula to find the slope. You could figure out the vertical change or the horizontal change, use that to find the slope, and we'll talk about all that right now. I'm going to go over page 13. You're going to work on page 14 as classwork, and then you're going to follow the instructions for IXL and work on that while I'm out. Okay. So the idea of slope says that stays the same whether you are finding it in a table, looking for it on a graph. It is still the change in y divided by the change in x. Step 1, find any 2 points on the line. Step 2, find the change in the y values and the change in the x values just like usual. Okay, so let's start with A. This is line A. You should be able to look at line A and see that this should have a positive slope when you give your answer. So this is increasing, going from left to right, it increases. The first thing you want to do is pick 2 points. Oh, that was a 2 points. All right, so I'm going to say you could pick this point. This is hard to do when you're looking at the camera. This point, this point, this point, or this point. The lines, I have to be honest, are a little off, and I was trying to figure out why, and it's because these boxes I don't think are completely square. So it's throwing off the lines a little bit, but these are supposed to be the points, I'll tell you that. So you can pick any 2 points. It doesn't matter. You can pick this one and this one. You can pick this one and this one. It doesn't matter which 2 points you pick. Now, the way I do this is to simply use that staircase thing we were doing yesterday. See how they like kind of go up like this? Doot, 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 doot. There's the staircase here. Ooh, look at it. Doot, 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 doot. So if you look at this and you just want to say, look at these 2 points, what's the vertical distance between these 2 points? What's the vertical change is what we're really saying between these 2 points. How many boxes in between them? There's 2. So the vertical change is 2. What's the vertical or the horizontal difference? What's the horizontal difference between this point and this point? How many boxes apart are they? 1. So what would the slope be? It's going to be the vertical change over the horizontal change, giving me 2 over 1, or you could just say the slope is 2. The other way to do this, and that's the easiest way from a graph, in my opinion. The other way to do this is to name the 2 points and either use the slope formula or put it in a data table. So let's start with the leftmost point. This is the coordinate 1, 3. So I'm going to write that down. 1, 3. X, Y. This is the coordinate 2, 4. So 1, 2, 1, 2, 3, 4, 5. Just kidding. 1, 2, 3, 4, 5. 2, 5. Now that you have the 2 points written down, you can find the change in y the way we did using the data table. So this goes up by 2, while the x values go up by 1, which means the vertical change is 2. So the change in y is 2. Change in x is 1, so your slope is going to simplify to 2. What's the symbol for slope? It's m. Okay. So that's 2 different ways. Okay, example B should come out to be a negative slope because this line is decreasing. So when you go to pick your points, you have, I would say, this one, this one, this one, and this one. My advice is that you be very careful if you're going to name the points and use the coordinates when you name any points that are on the axes. Is this 2, 0 or is this 0, 2? So if we are just going up 2 from the origin, this would be 0, 2. This would be 3, 0. A lot of people mix that up. They go back and forth. They kind of switch them up. So let's talk about the slope formula. Let's name 2 points. So let's use let's use these 2 points. So what is this point? Point 1, we're going to say 0, 2. We'll call that point 1. And then we'll call this point 2, which is at 3, 0. We're going to use the slope formula. So we picked the 2 points. This time we're going to use the slope formula. So this is going to be point 1. This is going to be point 2. And our slope formula reads m equals y2 minus y1 over x2 minus x1. Every single method we're using is just finding the vertical change compared to the horizontal, or the vertical component compared to the horizontal component. So however you get there, it doesn't really matter. So we're going to say this is x1, y1. This is x2, y2. And then you're just going to plug in the numbers. So we're going to do y2 minus y1. So 0 minus 2 over x2 minus x1. 3 minus 0. On the top, I get -2. On the bottom, I get 3. For your final answer, it doesn't matter where you place the minus sign or the negative sign. M equals -2/3. A lot of times when we give the answer, we put it in the middle. It really doesn't matter. Okay. Let's check that using our staircase method, or just, looking at the measurements here on the grid. So let's talk about these 2 points right here. What's the vertical change between these two? Like, what's the distance vertically between these two? Well, you'd have to go down 2, right? And then the horizontal change is this way, right? How much space is in between these points horizontally? 3. So you'd have to keep going down 2, right 3, down 2, right 3. See, look, watch. Down 2, right 3, down 2, right 3. So that's going to give you a slope of -2 over 3 again. This way is so much easier. Okay. Example C. How many points do you need? You just need 2 points. Once you pick your 2 points, you can either use this method, you can use the slope formula, or you can turn the coordinates into a data table. Whatever works for you right now, it works for me. So let's pick these. I'll pick this point, and I will pick, I guess that's the point, I guess that's the point, I guess that's the point. It's a little off. So I'm just going to tell you that it's supposed to go through these, okay? Not the best graph I've ever seen. So I can see that the vertical change is 1, horizontal change is 1, so it's going to be 1 over 1. It's an increasing slope, so the slope is 1. Using our coordinate method, what's the coordinate here? This is going to be 0, -2. Okay, putting it in a table. Oops. Okay, and this is the point 1, -1. Going from -2 to -1 is an increase of 1. Going from 0 to 1 is an increase of 1. So my slope is 1 over 1. That's the second way to use the same 2 points to find the slope. What's the other way? Use the slope formula. M equals y2 minus y1 over x2 minus x1. Our points were 0, -2, and 1, -1. Y2 minus y1, oopsie. Y2 minus y1 is going to be -1 minus -2. Dun, dun, dun. And then this is going to be 1 minus 0. So be careful here, because this is really 1 plus 2, which is 1. So fun. And 1 minus 0 is 1, giving me 1. So here's the moral of the story. How do you find slope? You pick 2 points, and then you can use any one of the 3 methods that we've talked about. I would assume that probably using the data table method, or just counting the boxes in between the dots or the points, would work best for you. So right now, complete page 14 and read the directions to go on to IXL, page 14 and 15. Page 14 and 15, how fun. 14 and 15. And then read the directions for IXL.com if you need more practice. Okay, have a great day. Bye.